Good morning, friends. The sun is shining in Alva. It is Tuesday morning, and I just want to start out with a few housekeeping things. I heard back from everybody in our class on the discussion board, but 2 people. So if anybody sees Austin Ferguson, please encourage him to reach out to me, or Luke, which Luke had stopped coming. But anyway, so definitely Austin. And then I'll give Luke a call. But I just thank you for doing the discussion board. I just needed to somehow get you information to kind of know what's going on, because I did not get to see you before we left before spring break. So thank you for working with us. Thank you for being willing. We know nothing more than you do as far as what the plan is. So as of right now, we are doing 2 weeks of instruction. Do we kind of know where we're headed? We might have a little inkling, but something tells me this will be the rest of our semester, but we're going to make the best of it, at least for this first 2 weeks. So I want to start in. So we finished up 4 sections of identities, and now we want to finish up the last 2 sections. So we're taking it one day at a time, and we will go from there. So today what we want to focus on is inverse trig functions, and what this is setting us up for is to be able to solve trig functions in the next section. So to actually be able to solve for theta, to get theta out of the trig function and solve for theta. So this is what that lesson is working up towards. So first of all, I want you to recall from college algebra that an inverse of a function reverses it. So addition, subtraction are inverses, multiplication, division are inverses. Another example is something squared, and taking a square root of it undoes it. Okay, so that's what we're kind of doing here. So basically the first 2, in chapter 2, we learned to go one direction. We found the sine of 30 degrees was 1/2. So now what we want to do is we want to go the other direction. We want to say at what angle is the sine 1/2, and we want to go back to 30 degrees. So you've definitely got to know your special angles to be able to do this. Okay. So to kind of set us up, for us to get inverses for trig functions, we have to have a one-to-one correspondence. And what that means is the graph has to cross the vertical line test and the horizontal line test. Now, if we look at, I'll come back to that. If we look at our sine graph, just in general as our sine graph, it is not passing the horizontal line test, because remember from college algebra, if it hits the graph twice, it fails the horizontal line test. So what we have to do is we have to create a restricted domain. And what that is on the x-axis, we have to basically restrict it down to just a section. So for sine, if we restrict sine down just from -pi/2 to pi/2, if we just look at that section in there that I put blue lines and red lines on, it passes the horizontal and vertical line test. So for sine, we want to create that restricted domain, and it's -pi/2 to pi/2. It has square brackets, so it does include those endpoints. And when we kind of think about that in terms of our unit circle, -pi/2 to pi/2 is the first and second quadrant. Okay, so our restricted domain for sine is first and second quadrant. So if we look at cosine and do the same thing, again, it fails the horizontal and vertical line test until we restrict it down from 0 to pi. Okay, sorry, I should have turned my phone off. So from 0 to pi, we want to restrict the domain down. It does include those endpoints, so it has those square brackets. So the restricted domain for cosine is on the first and second quadrants. Okay, first and second from 0 to pi. Okay, so then if we look at tangent, this basically goes back to, it's the same as sine, because it naturally has, if we remember the graph, it naturally has those vertical asymptotes at -pi/2 and pi/2, and that middle graph of tangent gives us a one-to-one function. So for tangent, again, same as sine, -pi/2 to pi/2 in the first and fourth quadrants. Okay, so what we have is inverse trig functions, and this is what they're called. So there's 2 different notations. They mean the same thing. If you are going into calculus, you will see arc sine, arc cosine, and arc tangent more than you see the little negative ones up here. Okay, now you can do these in your calculator, but the problem is your calculator will only give you the restricted domain, and for the next section we have to have every spot, not just the restricted domain. So make sure that you're doing these by hand. So basically, to find an inverse, you're trying to find out at what angle. My nose is running, hold on. I refuse to edit this out too, okay? I am, what you see is what you get in these videos. So for inverses, we're trying to find out what angle has a specific coordinate. So this is what you need to remember. Regular trig functions give us coordinates. So that's what we did in chapter 2 when we found the sine of 30 degrees. That gave us a coordinate of 1/2. Inverse trig functions give us angles. So anytime you're finding an inverse trig function, your solution should be an angle. Okay, so let's try it. I kind of gave you some questions here. So the question is the inverse sine of root 3 over 2. So the question is at what angle is the sine root 3 over 2? So we have 2 spots. So we can create that coordinate. So if sine is root 3 over 2, that means my cosine has to be 1/2, because if we think about our coordinates, that's the buddy system. That's the cosine and sine that go together. So sine is root 3 over 2 at 60 degrees, but it's also at 120 because it doesn't matter what the cosine is, whether it's positive or negative. So we have 60 and 120. So then the question you ask yourself is, which of these two places fall within the restricted domain of sine? Remember, sine is first and fourth quadrants, and so 60 or 120, the 60 falls in the first or the fourth. So we're looking for 60 degrees there. Okay, and then I worked through some of these again. I tried to write out the questions for you. At what angle is the cosine -1? And then there's only one place that happens, and it falls within the restricted domain. At what angle is sine negative root 2 over 2? So at what angle is the sine negative root 2 over 2? Okay, where is sine negative? It's negative in the third and fourth, because it's our sine is our y value, so where is y negative? So 225 or 315, which one falls within the restricted domain? The sine of sine 315. Now, these two tangents are a little bit harder, first of all, because you have to undo, because it's the combination of sine over cosine. So to find your coordinate that it goes back to, you have to unrationalize, and I tried to work through that with you on the left. And then it goes back to the coordinate root 3 over 2, 1/2. And because it's positive, remember 2 negatives will make a positive, so I either have the positive of it or I have both negative. So 30 or 210. So this happens, the restricted domain of tangent is 30. And then the same idea as tangent of -1. Where is tangent 1? Well, that means the sine and cosine have to be the same, so that's going to be our 45. So one's negative or the other's negative, so 315, 315 or 135, which one falls within the restricted domain of tangent? And again, tangent is first and fourth, so that's where the 315 is coming into play. Okay, so that's the biggest portion of this. You have to be able to go backwards from your coordinates. Okay, so chapter 2, we worked one direction. In this, we're going to go the other direction. So again, as I remind you, if you have not memorized your unit circle, go for it. Okay, so if you get cosecant, secant, and cotangent, the inverses of those, these are used to find the inverses, and what they do is they convert to sine, cosine, and tangent. Now, be very careful here because this is not the same as identities. So when we do our identities, we know cosecant is 1 over sine of x. That is not this statement right here, or these three statements. So please make sure that you go, anytime you have inverse cosecant, inverse secant, or inverse cotangent, go back to these formulas. With the cotangent, inverse cotangent, if you're working with a radian or you want a radian out, then you use pi over 2 minus inverse tangent. If you're wanting a degree, you have to use the 90 degrees minus the inverse tangent. Okay, and then this box is just talking about that it has to, again, be within the restricted domain. Okay, the next information is composite trig functions. So in college algebra, we talked about inverse trig functions, or we talked about composite functions. Okay, and composite functions, that was where F was composed of G and G was composed of F when we put one into the other. Same idea here. On the left-hand side, we have our regular trig functions on the outside with our inverses on the inside. And again, what that does is it gets us out that angle. It eliminates the trig function. And the ones we'll use most are on the right-hand side, and we'll definitely use these in section 3.6, the end of 3.5 and 3.6 on Thursday. So inverse on the outside, regular trig function on the inside, that gets us at our angle. So we will use those. And again, this is the box that's discussing the restricted domain. So if we do composite inverse functions, we can combine these, and the key here to remember is inverses give us angles, regular functions give us coordinates. Always remember to work from the inside out. The inside out. So use the parentheses first. This is a regular trig function, so it should give us a coordinate. And that's where we get the -1/2. And then when we take the inverse, we get out an angle. The restricted domain still applies. Okay, so I tried to show several bits of work for you there. Okay, this bottom one, the sine of the inverse cosecant of 2, remember this is where you're going to use your formula for the inverse cosecant. And then this sine of the inverse sine of 1/2 is your composite function. Okay, if you go back and look at it. Now, if you don't see that it's a composite function, you can work the below part in green, and that is just showing you that you're just, the sine of the inverse sine of 1/2 is 30, and then the sine of the 30 is 1/2, so you can still do it that way. Now, if you have something with a fraction in this case, you're going to make a triangle, and we will see another example of that. So making a triangle does the inside portion, and then the cosine of that triangle is 24/25. Probably should have turned my email off too. Okay, so this last one is kind of just applying some things. So using the sum of two angle identities. So remember that inverses are angles. So this first part, the inverse sine of 3/5 is just an angle alpha. The inverse cosine of -5/13 is just an angle beta. And so we can create triangles from those. They're right down here below. And then we can use our trig function. Okay, our trig identity, the sum of two angle identity, that's where the cosine alpha, or the sine alpha cosine beta plus cosine alpha sine beta is coming from. So then you can see where we substituted in. The first two, you can use your composite functions to get out your coordinates. The last two, you have to create triangles, and that's what's down below. So, okay, that finishes this up. Again, if you have questions, I can always do a Zoom meeting with you. Just reach out to me and I can set that up. You may have heard a lot about Zoom meetings. Basically, I send you a link and you just click on it and you connect to me. So very easy on your end. You do not have to have Zoom. So it's just basically a way that I can conference call with you. And you can show me things and I can see your face, and you can post things. So if you have any questions, let me know. Probably the easiest way to do this is, I should have said this at the beginning, but copy down the notes. We know handwriting works best to learn things, so copy down the notes and then watch the video as we go through it. I do have a quiz for this. I haven't figured out how to give it to you yet. Most likely if you have access to WebAssign. So WebAssign has made everything for free, and so what I'm going to ask you guys to do is log into WebAssign and get enrolled in our course. It's not going to cost you a thing, and with that does come an ebook. So I will be posting information on how to get you logged into WebAssign to be able to take some quizzes. So that will be in a different video and a different email. Have a great day. Be sure to email me or reach out to me if you have questions. I'm always available by phone or email. Even when I'm home, I'm directing all my phone calls to my home. So, okay, have a great day. Enjoy the sunshine. Get outside and look for those teddy bears if you're in Alva.